Hello everybody, this is the sixth video clip for chapter 2, and today we are going to talk about the higher derivative. Okay, as we told you previously that for this one, the f prime of x, okay, this one is so called the first derivative of a function f. Okay, and if you look at one example, for example, let's say like x cubed, then as you find the first derivative, it becomes 3x squared. Okay, so this one is another function, right? So as a function, you can find a derivative of this function one more time. Okay, so we can use at the beginning, we can use this notation because it is a derivative of this f prime function, right? And it will be what? The 3 will be copy, right? And the derivative go to x squared, which is 2x, and you end up with 6x. Okay. However, instead of using this kind of keep using this kind of notation, we are going to say that, hey, this one is just simply f double prime, okay, f double prime of this function x, okay, and we are going to call this one as the second derivative, okay, a second derivative of this function, okay. So if your f is differentiable function, so the derivative f prime is also a function, as we can see from the example. So it means that your f prime may have derivative of its own, and we are going to denote it by f double prime like that, okay? So this new function is called the second derivative. And actually we can keep, for example, if you can see that this one, your f double prime, is still another function, right? So actually you can keep finding the third derivative, okay? For example, f triple prime, it will be just 6, and then a derivative of x is 1, right? So it will be 6. And then the fourth derivative is start to be what? Start to be 0 of, of this function x cubed, right? Okay. So as you can notice from this example, you may see that if you start from a polynomial, okay, if you start from a polynomial, at a certain step, you are going to get a higher derivative of this polynomial become a 0, okay. So this one, we challenge you a little bit that if you start from a polynomial of degree n, then at which order of the derivative of f, okay, that your derivative start to be 0, okay. So which k smallest that it will start that your derivative start to be 0, okay. So actually, as we told that we can also compute the third, the fourth, and the higher derivative, okay, of the f. So we just finding further derivative 4 times, 3 times, or any time that we want, okay. And the notation of the nth derivative, we use f and then superscript parenthesis n, okay. Don't forget the parenthesis. So this one is the nth derivative of f, okay. So usually for the prime, okay, for the prime notation, we are going to use it until f triple prime, but then larger than that we start to use this notation instead, okay. So for example, if you look at the this function f of x equals to x cubed to x squared for x and cosine of x, then if you want to find the fourth derivative, you need to do it like one by one. So first, you find the first derivative of a function, which will be 3x squared minus 2, and then this one goes to x squared, right? So 2x, and then 4, derivative of x become 1, and then derivative of cosine is simply negative sign, okay. So this one becomes 3x squared, 4x, 4 minus sine, okay. So the second derivative is just simply a derivative of this one, 3x squared minus 4x, 4, and then minus psi, okay? So each one of them becomes what? 3, 2x, 4, and 1, and then a derivative of a constant becomes a 0, and then a derivative of psi becomes a what? Positive cosine, right? Okay, but you still have that negative in front, so you have negative cosine out of it. So we got what? 6x minus 4 minus cosine. Are we okay? Now, the third derivative is just the further derivative from this one, 6x 4 cosine. Okay, so you have 6 and 1. You got 0, right? Because it is a constant. And then a derivative of cosine becomes a negative sign. So it becomes 6 plus sine. Okay, now what will be your fourth derivative? Okay, so it starts to be what? 0. And then derivative of sine becomes a positive cosine. So you end up with a cosine. Okay, so if we challenge you a little bit to find the 10th or the 20th uh, um, order derivative of this function, what it will be, okay? Can you look at from this pattern, okay? And then because actually the pattern is not that difficult, right? Of course, all the polynomial already gone. So the thing that keep uh, appearing is either the sine or cosine, you see, a sine or a cosine coming back and forth. Okay, however, the either positive or negative, that you need to think. Okay, you need to see a pattern and see like how it goes. Okay, all right. How about this one? Okay, this is another notation. All right, the first notation that we have is the f prime equals to dy by dx or df by dx, right? So your f double prime, it means that you take this operator one more time. We okay? So by taking this operator, your d becomes twice, and then your dx becomes a square. Okay, but then usually we don't write the parentheses, so we write this way. Okay, all right, and then we read d2y by dx square. Okay, this one d2y by dx square. Okay, this is how we read. All right, and it becomes the second derivative. So it means that if we keep go further, the nth derivative of this function, okay, so we can use the notation dny by dxn like this. Okay, so it means that you keep finding a derivative. Okay. So here, if you want to find this one, it means that you need to find the second derivative of this function. So the dy by dx, okay? First of all, you can see that there are two functions multiply. This one, we can rewrite it into x raised to the power 1/2 plus 2. So you use the product rule, right? So it is the first, and then derivative of the second, which is 1/2 x raised to the power negative 1/2 and 0, okay? And then plus the second, which is this one, derivative of the first, which is cosine, okay? And if you want, you can simplify a little bit. It will be 1/2 x raised to the power negative 1/2 side of x, and then this one 1/2 and 2 cosine of x. All right, so to find the second derivative, it's just simply a derivative of this whole thing, okay, sine x, and this one plus 2 cosine of x. And you need to look at it this way, that the first term depends on two functions multiply. The second terms also depends on two functions multiply. So both terms, you need to use a product rule again. Okay, so the first one, the 1/2 can be out, right? And then this one, the first derivative of the second, which is the sine become a cosine, plus the second, which is your sine, and then the derivative of the first, which will be what? Negative 1/2 x raised to the power negative 3/2. Okay, so this is your first term product rule. And then the second term product rule, it will be what? The first derivative of the second, which is a cosine, so become a negative sine, plus the second, and then derivative of the first, it is like 1/2 x raised to the power negative 1/2 and then 0. Okay, actually this can be good enough to be your final answer. However, let us rewrite it a little bit. So this one becomes 1/2 square root of x cosine x, and this one, don't forget that here you need to distribute. It becomes 1/4 x square root of x and then side of x, because you see here x raised to the power negative 3/2. It is like x raised to the power 1 and x raised to the power 1/2, but it is at the bottom, so it becomes what? X and square root of x. Okay, and now this one, oh, it is negative, right? So you have square root of x plus 2 and then side of x with the negative here, and this one you got 1/2 square root of x multiplied by cosine of x. Okay, so this can be your second derivative. Okay, so we would like you to do the exercise on section 3.3, 1 to 16, 21 to 24, and 31. Okay, so we are going to stop this video clip right here, and maybe if you want, then you can find, for example, for this example, you may need to find one more derivative, okay, with respect to x, okay, d3y by dx cubed, to see like how it goes, because you are going to use the product rule for several terms, okay, and sometimes it will be better if you, for example, see, oh, here you can combine. So we got sorry, so we got this one, right? Actually, it can be further simplified because you can combine like this, and then minus 1/4 x square root of x and square root of x plus 2 and side of x, so that you don't really need to do a product rule 4 times, but instead you do only 2 times, okay, with this function. All right, okay, to find the third derivative. Okay, so we'll see you on the next video clip. Bye bye.